Welcome to the DIY Honda Garage channel. The DTC P0172 indicates that the fuel system is too rich, meaning there is an excessive amount of fuel in relation to the air entering the engine. This code is associated with the fuel injection system and is crucial for maintaining the correct air-fuel mixture necessary for optimal engine performance. In modern Honda vehicles like the Accord, the fuel system is primarily controlled by the Powertrain Control Module, PCM, which monitors various parameters to achieve the ideal combustion ratio. When the PCM detects that the air-fuel mixture is richer than expected, it triggers the P0172 code. The fuel injectors, oxygen sensors, and various sensors like the MAF and MAP play vital roles in determining the proper mixture. Location-wise, components involved in this system are distributed throughout the engine bay and exhaust system, making inspection critical for accurate diagnostics. The DTC P0172, labeled as Fuel System Too Rich, points to a specific issue within the vehicle's fuel system. The components affected primarily include fuel injectors, the air-fuel ratio, AF sensor, and the engine control unit, ECU. The fuel injectors introduce fuel into the combustion chamber, where it mixes with air to facilitate combustion. If these injectors malfunction or become clogged, they can deliver excessive fuel, leading to a rich mixture. Additionally, the AF sensor detects the composition of the exhaust gases and communicates with the ECU to adjust the fuel delivery accordingly. This problem typically manifests when the vehicle is idling or under moderate load. The components involved reside mainly in the engine compartment, including the intake manifold for the air intake, fuel rail for injectors, and exhaust for the AF sensor. Several factors can lead to the P0172 error code. Firstly, faulty fuel injectors can deliver more fuel than necessary, contributing to a rich mixture. If they leak or have damaged seals, the fuel flow can also increase unexpectedly. Secondly, a defective AF sensor may fail to accurately measure the air-fuel ratio, prompting the PCM to deliver more fuel than what is needed. Thirdly, issues with the mass airflow, MAF, sensor can incorrectly assess the amount of incoming air, leading to erroneous fuel adjustments. Lastly, contaminated engine oil can affect system performance, where degraded oil may cause internal engine components to malfunction, indirectly affecting fuel delivery. Each of these potential causes necessitates careful inspection to pinpoint the exact issue. The P0172 code can lead to a myriad of symptoms that affect vehicle performance. Poor engine performance is common, where drivers might notice a lack of power or hesitation while accelerating. Rough idling is another prevalent symptom, where the engine may struggle to maintain stable RPMs when at a stop. Increased emissions can also occur as a result of the richer fuel mixture, potentially leading to a failure during emissions testing. Additionally, a noticeable fuel smell from the exhaust is indicative of unburned fuel exiting the system, which can be frustrating for the driver and harmful to the environment. Understanding these symptoms helps in diagnosing not just the P0172 code, but also potential other underlying issues. The first step in troubleshooting the P0172 code involves verifying the problem by starting the engine and allowing it to idle without any load, such as the transmission in park or neutral. During this phase, monitoring the AFFB, or short-term fuel trim, is crucial. The threshold for a normal reading is less than 0.79. Using the HDS, or Honda Diagnostic System, the technician should confirm if the readings fall within this threshold. If the AFFB reading is too low, it indicates a rich condition, prompting the technician to move forward to the next steps in troubleshooting. If the reading is acceptable, the technician must carry out further diagnostic procedures to assess other potential issues affecting the fuel system. In the second troubleshooting step, the technician must analyze the onboard snapshot, which provides a historical look at vehicle parameters when the AFFB was at its lowest point. This involves recording critical data such as engine speed, vehicle speed, throttle position, rel-TP sensor, and accelerator pedal position, APP sensor. After gathering this information, the technician is required to drive the vehicle under similar conditions to monitor whether the AFFB remains within the acceptable range, while evaluating these parameters again. This comparative analysis is critical for identifying whether the rich condition is consistent across various driving scenarios. If discrepancies arise, further testing may be necessary to identify any faults or underlying issues. The third troubleshooting step requires checking the engine oil's quality to determine if contamination is present. This involves allowing the engine to idle while gently pinching the positive crankcase ventilation, PCV, hose to observe any changes in the AFFB. Utilizing the HDS again, the technician checks if the AFFB reading remains below the established threshold of 0.79. If the AFFB drops significantly while pinching the PCV hose, it may indicate an underlying issue that requires further investigation. Conversely, if the reading is normal, it suggests that the engine oil is not contaminated. If contamination is found, identifying the cause, such as faulty injectors, will be necessary to resolve the problem and maintain engine integrity. Step 4 involves evaluating the evap canister purge valve, which plays a vital role in managing fuel vapors from the fuel tank. To begin, the technician must turn the vehicle off and disconnect the 2P connector from the evap canister purge valve. Following this, the valve should be removed along with its connected vacuum hose. At this stage, a vacuum pump gauge is connected to the purge valve, allowing for accurate measurement of vacuum levels while starting the engine. If the vacuum pump indicates vacuum while the engine runs, it reveals that fuel vapor from the canister is entering the intake manifold excessively during warm conditions. This creates a rich mixture, potentially causing stalling. Should this be the case, replacing the evap canister purge valve may be warranted. In troubleshooting step 5, the technician must perform a comprehensive check of the throttle body. First, the vehicle should be turned off to ensure safety during inspection and to prepare for the testing process. The next action involves verifying whether the throttle body is within specified limits. If the readings fall outside these limits, it indicates carbon accumulation that could impact airflow and consequently the air-fuel mixture. If cleaning is required, attention to detail is essential to ensure all throttle body components are free from carbon buildup and function seamlessly. Once cleaned, the technician can restart the vehicle and continue through the following diagnostic steps, ensuring that proper airflow is restored. Step 6 focuses on evaluating the performance of the fuel injectors. This begins with powering the vehicle to the off position, followed by switching it to on. Utilizing the HDS, any DTC present must be cleared before performing the cylinder air-fuel ratio, cylinder AF, test 3 times. This test assesses the functionality of the injectors. If the test indicates a fail result for one or more cylinders, this signifies that the injectors are not performing correctly, necessitating their replacement as a set. Performing this test under specified conditions, such as AC off and all electrical loads turned off, ensures that readings are accurate and reflective of true injector performance. critical in identifying and rectifying issues leading to the P0172 code. In troubleshooting step 7, low fuel pressure is assessed by starting the engine and allowing it to idle. This step requires careful monitoring of the fuel pressure, while ensuring that the AFFB remains below the critical level of 0.79. The technician should utilize a fuel pressure gauge to verify whether fuel pressure is within specified limits. If the fuel pressure is not adequate, it can trigger a cascade of issues, leading to an excessively rich fuel mixture. Should the fuel pressure test return a result that indicates outside the acceptable range, the technician must replace the fuel tank unit to rectify the starting point of fuel delivery problems. If fuel pressure is normal, this indicates that the system is operating as expected, allowing the technician to proceed to further steps. In the 8th step, the high fuel pressure on the system is tested. Begin by turning the vehicle to the off mode, then switch it to on. The DTC must be cleared using the HDS before starting the engine again. The technician should hold the engine at 3,000 RPM without load, ensuring that the radiator fan activates before letting it idle. Employing the HDS, the technician must select the direct injection fuel pressure test to determine the operational status of the high-pressure fuel side. If the HDS indicates normal operation, this confirms that the high-pressure delivery is functioning properly, allowing the technician to move to the next phase. Conversely, if irregularities are detected, further troubleshooting targeting related codes like P0087 or P0088 should be performed to address any faults. Step 9 involves replacing the fuel as a diagnostic measure to eliminate the possibility of fuel-related issues contributing to the rich condition. First, the vehicle should be turned off before draining the existing fuel and refilling the tank with a known good fuel source. This step reestablishes a baseline for fuel quality, which can often be the root cause of the P0172 code, particularly when this rich condition appears shortly after refueling. After reinstalling the fresh fuel, starting the engine again and allowing it to idle will provide further data regarding the AFFB levels. By operating the vehicle under the same conditions that previously caused a low AFFB reading, this test can confirm whether the replaced fuel played a role in the error code. The results from this step will guide the technician on whether to continue with further troubleshooting or to consider other components next. During the 10th step of troubleshooting, the emphasis is placed on monitoring the engine coolant temperature, ECT sensor, and engine speed. The technician must ensure that the ECT sensor reads above 158 degrees Fahrenheit, 70 degrees Celsius, with full electrical loads off, preparing to facilitate accurate testing of the MAF sensor readings. Utilizing the HDS, the technician holds the engine speed steady at 2,500 RPM for a 30-second duration. During this period, the MAF sensor's output must fall within the specified range of 4.1 to 5.7 grams per second, G/S. Discrepancies in the MAF sensor reading can indicate dependent faults, leading to an incorrect air-fuel mixture. If the readings do not align, it's crucial to investigate for airbox issues, like cracked or incorrectly installed components, or possibly replacing the MAF/IAT sensor as outlined in the troubleshooting protocol. In the 11th step, the focus shifts to replacing the air-fuel AF sensor, designated as Sensor 1, if diagnostics show earlier conditions point to its failure. After confirming that all necessary precautions are in place and turning the vehicle to off mode, the old sensor is replaced with a known good sensor. After replacement, the vehicle should be started, and the technician monitors engine operations. permitting the vehicle to idle while running under similar conditions to what previously caused the low AF/FB reading. Evaluating the HDS results while driving helps ascertain whether the newly installed sensor corrects the rich condition. If the AF/FB values still indicate excess fuel, it implies the need for further action, such as returning to the original sensor and advancing to the next diagnostics. The final step in troubleshooting involves the replacement of fuel injectors as a complete set if all prior checks have not resolved the P0172 code. This action is essential when tests indicate injector malfunction or when erratic fuel delivery persists. After turning the vehicle to off mode, the old injectors are switched out for a known good set. Once the new injectors are fitted, the engine should be started and allowed to idle as the technician observes performance metrics for consistency with the AF/FB readings. Should results yield no improvement, the technician must consider other electronic control components, such as the Powertrain Control Module (PCM), to ensure the rich fuel condition is resolved. This comprehensive approach eliminates variables and helps pinpoint the exact source of the DTC error. After completing the required repairs or replacements based on the diagnosis of the P0172 code, final verification is mandatory. The technician should use the Honda Diagnostic System, HDS, to recheck the vehicle systems. The essential step is clearing the DTC to ensure all previous error codes are removed from the memory, which also allows for fresh readings during subsequent tests. Following this, it's crucial to evaluate performance metrics while allowing the vehicle to operate under normal conditions. Successful verification occurs when no new codes arise and the vehicle runs efficiently, without presenting the initial symptoms of poor performance or rich mixture. Consistent confirmation at this stage supports the notion that the repair engaged has indeed resolved the underlying issues. Preventive maintenance is crucial to avoid future occurrences of error codes like P0172. Regular checks of the fuel system, including the fuel injectors, are advisable to ensure they are functioning correctly and efficiently. It's wise to replace fuel filters at scheduled intervals to avoid clogging and ensure proper flow. Monitoring overall engine performance often can preemptively catch signs of issues before they manifest into error codes, thus allowing for prompt remedial action. Additionally, using high-quality fuels and keeping an eye on oil quality can prevent contaminants that compromise injector performance. A comprehensive approach to vehicle maintenance minimizes the risk of rich fuel mixtures and enhances the longevity of the engine. In conclusion, understanding the DTC P0172, which indicates that the fuel system is too rich, is vital for Honda Accord owners and technicians alike. This diagnostic trouble code stems from various potential causes, ranging from faulty fuel injectors to sensor malfunctions. The systematic troubleshooting steps outlined help in accurately diagnosing the underlying issue effectively. Each step addresses specific components, allowing technicians to hone in on the root cause of the rich mixture problem. Engaging in thorough preventive maintenance strategies, like regular evaluations of the fuel system and monitoring engine performance, can significantly reduce the incidence of such DTCs in the future. Moving ahead with these practices ensures both effective vehicle operation and a consistently well-maintained engine. Please like and subscribe to the channel. See you next time.